Hello all, in this video I'm making some chess pieces to go with my most recent Battlefield Chessboard build. I finished the chessboard a while ago but struggled to find the motivation to make the pieces because of how cold it's been outside. Eventually I forced myself to get out to the shop despite the cold though, and here we are. My chess pieces have been called minimalist, and while that's not the intention, I think it's accurate. My chess pieces have minimal details because I'm not a highly skilled turner and don't trust myself at all to hand carve any pieces. I do think they look pretty good though. With all of that in mind, I'll shift focus to the actual process now. The first couple steps I did off camera, and that's really just prepping the blanks for the lathe. I basically make all 32 blocks of wood to the necessary sizes and drill a hole in one end so that I can mount them all to the screw chuck on the lathe. Once the blanks are on the lathe, I turn them down to be cylinders just a little bit larger than the largest diameter of each piece. Sometimes I'll do this step first for a bunch of pieces at once, and sometimes I'll just make it the first thing I do for each piece. I did this all at once for the pawns, so that's what we're watching now while I explain this and a couple more things. For each piece, I made a storyboard out of cardboard because I'm cheap. I actually didn't make the storyboards until after I made the maple pawns, so that's why you haven't seen it in the video yet. Anyway, the storyboard allows me to consistently mark certain points on each piece as I turn them. For example, all of the pawns have an overall height of about 45 millimeters, so on the storyboard, I'll mark a line 45 millimeters from the leftmost side. Then I just line up the storyboard while the piece is on the lathe and make a mark where the line is on the storyboard. This is the first time I've done this though, so I also made sure to double check the measurements of critical things like the overall height prior to fully committing. In addition to the overall height, each piece also has a narrowest point, so I'll mark the location of the narrowest point on the storyboard, then I'll turn that spot down to be the appropriate diameter and then just sort of flow the high points into that low point. Every piece other than the pawn has some additional points that need to be marked out, but I'll tell you what those are when we get there. That last clip was turning a pawn down to its final dimensions, and the pawns are pretty simple, so I think we can move on to the rook now. In addition to the overall height and the narrowest point, the rook has a top section that's all the same diameter. That section is something like 9 millimeters, so I have a mark on the storyboard at 49 millimeters for the overall height, another at 35 millimeters for the narrowest point, and one more at 40 millimeters for the beginning of the top section. There's also a cavity in the top of the rook. In real life I did this after turning the rest of the pieces. I could edit the video so you see it now, but I don't really want to, so you have to wait or skip forward if you're excited for that. You may have noticed that I've already used two different camera angles at this point, and there will soon be a third. I'm not really sure which, if any, are best, so I would really appreciate it if you could let me know in the comments which you prefer. Alright, this first stage of the rook is pretty much done, which means the knight is next. Personally, when I've watched videos about making chess pieces, it's mostly been for the knight. Unfortunately, I can't tell you that the knight is done completely on the lathe, but I do make my knight in a sort of unique way. Because of my lack of lathe experience, the knight is the trickiest piece for me while it's on the lathe, even though it's a pretty simple shape. I basically get the base diameter established, the narrowest point established, and then turn a ball at the top. The ball is what's tricky for me because I find it hard to make a consistent ball across different pieces, but so far I've done okay and it turns out okay in the end. The reason I turn a ball has to do with how I make the knight look like a horse, and that will make sense later when I get to that part. Because I turn a ball though, I have the location of the ball center marked on my storyboard. The bishops are about as simple as the pawns, so I'll just take this time to ask you to consider liking and subscribing if you sort of like my content and want to see what I make next. I'm not sure what my next project will be, but I do think I'll be making another set of dominoes this year. I'm not super excited about that because there's a lot of hand sanding involved, but I'm hoping to streamline the process, which should make it a little less painful. Next up is the queens. They're a lot like the pawns, but they're a little tricky because they have a ring at what would be their narrowest point. That's pretty straightforward to understand though, so what I'll explain right now instead of how I make the ring is the base diameter of each piece. If you look closely where the base of the queen is mounted on the lathe, you'll see that there's a different piece of wood that it's butted up against than what you saw before this point. This is because I created a little cylinder for each unique piece. I turned it in a way that the part that the piece touches has the same diameter as that piece's base. The queen's base diameter is something like 28 millimeters, so this little cylinder between it and the screw chuck has a diameter of 28 millimeters. This way, I can just turn the queen down to be flush with the cylinder instead of stopping and checking constantly until I get to the right diameter or accidentally go too small. This cylinder has the added benefit of having a shoulder that my speed square can ride against. This is beneficial because I can hold the storyboard on the speed square and bump the speed square up against the shoulder of the cylinder so that I have a solid and consistent reference point. You may have noticed that the queen you just saw was walnut instead of maple. You also may have been wondering when I would get to the walnut pieces. Well, I actually recorded everything on the lathe this time, but in the interest of keeping the video short-ish and interesting, I decided to just show one wood for each piece, and considering the walnut is gorgeous and the king and queen look the best, I thought I'd save the walnut turning videos for them. Except you get to see walnut and maple for the king because I do have more to talk about during the making of the king. I actually had to remake the king a couple times because of stupid mistakes. I don't trust myself to carve a typical cross, so I make a sort of halo crown thing, and that crown is about 5 millimeters tall and has a smaller diameter than the part of the king it attaches to. We'll call that the head. One of my mistakes was turning the diameter at the overall height to be the diameter of the head and then tapering down like I did with the other pieces. Because of the taper from the top, the diameter at the head was too small. Fortunately, this led to a tweak in the king's design that I like better. In order to not make the same mistake again, I turned the entire top 10 millimeters or so to be the larger diameter prior to making the crown. This resulted in the head having a long section sort of like a rook, while my previous king designs had a sort of bulbous taper from the head to the narrowest point. I think the next time I make chess pieces, I'll make the storyboards out of some thin plywood and have notches that will act as outside calipers, which will let me know once I've gotten certain areas turned down to the right diameter. This will prevent me from constantly adjusting the outside calipers for each point I need to check. At this point, almost all of the lathe work is done, so I can move on to the extra details of the knights and bishops. To do this, I make some marks at key points on the lathe to reference in the next steps. For the bishop, I just need to remove excess material at an angle. I'm basically aiming for a straight line from the mark I made on the lathe to the edge on the top of the opposite side. To achieve this and ensure I get a nice straight cut and a flat surface, I made this little jig that holds the chess piece. It's basically just a small platform with a wall and a screw going through the wall that the chess piece mounts to. I also hot glued a little wedge underneath each chess piece to make sure it's fully supported when cutting. On the bandsaw, I just get the cuts close and then take the pieces over to the oscillating belt sander to finish it off. This part took a shockingly long time, which is why I used the bandsaw to remove most of the material before going to the belt sander. For the knights, the first step is basically the same as the bishop, but I needed to do it on both sides, and I went to specific points near the top center of each piece. The hardest part of this process was making the lines for me to follow on the bandsaw and sander, and now that I think about it, that's probably not really necessary since it's point to point in a very short distance. The work on the oscillating sander is similar, but I have to use the ends of the sander so that I don't sand away part of the knight that I want to keep. There's also an additional step on the sander that's basically the same, but just a different angle to define the front of the horse's head. I probably shouldn't have recorded it in time-lapse though. The next step for the knight is to define the neck, snout, and chest area kind of all at once. To do this, I keep the knight on the mounting jig and just use a sanding drum on a rotary tool to go deep into the piece at a certain point and then work the sander up toward the top of the piece a little bit. I get all the knights to the same point and then do some touch-ups off camera to try and make sure they're all as consistent as I can get them. The last thing I do for the knights is to define the ears. To do this, I basically do the same thing as the prior step, but on the back of the top of the piece and much shallower. This is another step that was quicker than I anticipated, so I probably shouldn't have recorded in time-lapse, but hopefully you can see what I'm doing. It's pretty simple. For the rooks, the last step I do is to make a recess in the top of the piece. I do like the look of the standard castle type rooks, but again, I don't trust myself to carve details like that. To make this recess, I use a steady rest because once the tailstock support is removed, the pieces often have a bit of run out. This is the first time I've used a steady rest and I love it. It didn't give absolutely perfect results, but that may be due to my lack of experience with it. Whatever the case, the results were nearly perfect and I'm very happy. Actually, creating the recess is fairly simple. I just use the edge of the skew to define the rim, and then I use a round carbide scraper to remove the inner material. I like the idea of a flat bottom rather than a rounded one, but that's significantly harder to execute. With the rooks done, that's pretty much all of the stressful, risky work done. So now I finally feel comfortable enough to remove the excess material off of the remaining pieces and taking them off the lathe. This seems like a super straightforward procedure, but in my experience, if you use just the parting tool all the way to the center of the wood, it'll tear out some of the fibers from the top center of the piece. To avoid this, I use the parting tool almost all the way to the center and then use the end of the skew to leave a little nub on the top of the piece, which can easily be filed off while the lathe is running. The steady rest isn't really necessary for this process because by the time the piece starts to wobble, the excess wood is basically already removed and any unpleasantries caused by the wobble will be addressed with hand sanding anyway. So I went out of character and actually recorded a bunch of sanding because I wanted to show you how long and terrible sanding all of the chess pieces by hand is. However, after I did the first grit, I realized there's a much better way to do the sanding, so rather than show you the very wrong way, I'm showing you the sort of wrong way. The sort of wrong way is to sand the top of the piece by hand and then sand a couple grits on the lathe on its slowest setting and then do the final grit with a mop sander. I didn't know mop sanders were a thing or that they worked so well until after I finished the first grit by hand. In the future, I'm going to use a mop sander for each grit on the lathe at a higher speed and then turn the lathe down to its lowest speed in order to sand out the cross-grain sanding scratches with the final grit. When doing it that way, it's critical that all of the sanding happens prior to parting off the excess material. Once the excess material is removed, there will be significant runout and the sanding won't be even unless you run the lathe at its slowest setting like I am here, but that drastically increases the amount of time it takes to do all of the sanding. If you're wondering why I'm not using a mop sander for all of the earlier grits here, it's because I only have the one high grit mop sander at the moment. You might notice that I actually have a second mop sander that I'm switching to, but I'm not counting that because it's nylon and they dulled super fast, so I'm just using it here to burnish the wood since I did the first half of the pieces with just nylon, which left a burnished appearance, and I wanted to make the appearance even. With all that sanding done, I can finally move on to the last few steps, which are not incredibly stressful. The first of those steps is to expand the hole that's currently in the bottom of each piece so that they're large enough to accept the neodymium magnets. To do this, I work my way up to a 17/64 drill bit, which is just over a 1/4 inch, but I don't go straight for the 17/64 because it might not self-center, which would result in a wonky hole and potentially off-centered magnet. Next up is installing the magnets. Surprise, surprise. To install the magnets, I normally use CA glue, but CA glue is pretty unforgiving, so this time I went with an epoxy paste. This came with its own set of challenges, but I really like having the ability to correct any magnets that somehow get the polarity reversed. The way I do this is to put some epoxy paste in the hole, get a single magnet on a flat metal surface, which is a chisel in this case, and that chisel has been covered with parchment paper, and then I use that to press the magnet into the hole. Once it's in the hole, I slide the chisel off the chess piece. The idea is to keep the magnet nice and flush with the surface. You could drive yourself crazy and make sure the hole is exactly as deep as it needs to be, but I find this to be a lot easier. In order to make sure I don't screw up the polarity, the first thing I do is basically a trial run. I stick the magnet to the chisel, separate one magnet from the rest, stick that into a chess piece, cover the magnet with tape, and make sure that chess piece is attracted to the chessboard. If it is, then I tape the end of the magnet stick that did not get pressed into that chisel. This way I can't accidentally take a magnet from the wrong side. It's still possible the magnet flips on me sometime in this process without me noticing, but that's why I switched to epoxy paste. I apologize for this upcoming camera angle. I wasn't sure what the best angle would be, so I kind of just let you see it all, and watching it now, I don't love it. Anyway, for the finish, the pieces get 2 coats of a wipe-on polyurethane. I really don't love the wipe-on polyurethane, but I haven't found a better finish for my chessboards and pieces yet. As you can see, the chess pieces are all stuck on some bar clamps. This is so that I can apply finish everywhere but the top of the chess piece while holding it, and then apply finish to just the top after setting it down. If I set it down on a non-metal surface, applying the finish to the tops of the pieces would knock them over. The last step gets done twice, and that last step is applying flocking. Prior to applying the flocking, I get all of the pieces spread out in a way that they're as stable as they can be and far enough from each other that they won't get knocked over by neighboring magnets. This is important because if that happens, all hell could break loose and I might have to wipe them all down and start over. To actually apply the flocking, I use wood glue as an adhesive. The flocking manufacturers recommend using their colored flocking specific paint, but in my experience, wood glue works just fine on small flat surfaces. So I take a piece, carefully spread a layer of wood glue on just the bottom, and dust the wood glue with the flocking. To dust the wood glue, I just shake a plastic cup that I've drilled small holes into and filled with flocking. Once it's dusted, I knock the piece around to make sure all of the glue has indeed been coated, and then top it off with some more flocking. I then very carefully set the piece down and start on the next one. Once all of the pieces have been flocked, I pray that there will not be an earthquake before the glue cures. After a few hours, the glue cures enough that I can blast everything with compressed air to remove any loose flocking and apply the second coat. I should warn you that once the glue cures, removing the flocking and starting over probably is not an option. I haven't had to do it with chess pieces just yet, but on another project I didn't like how the flocking turned out, so I tried to sand it away and was simply unable to. So here are the pieces after letting the glue cure and air blasting the flocking to remove any excess. Unfortunately, I couldn't really get the camera to focus properly on the rooks while they were on the center of the screen, but if you wait until the rook is on the right side of the screen, it should be in focus a bit more to check out. I am so close to loving how these turned out, which is pretty good for me. After they were all done, I did find a couple little details that bugged me, but nothing that bothers me too much. I think I can only really make out one of the issues in the video, but leave a comment below if you see any issues with the pieces, or just to let me know what you think. Thanks for watching.
think I